Audio Jungle. Audio Jungle.
Hello, welcome back. In this lesson, we'll give an overview of the general purpose input-output, the GPIO module. Okay, so first things first, in microcontrollers, the pins are grouped into ports, such that we have port A, port B, port C, port D, etc. So you would hear us mention something like PA1. When we say PA1, we mean port A, pin 1. In the same way, we have a pin here called PD7. This means port D, pin 7. So there's the basics. Microcontroller pins are grouped into ports. Okay. So also, we say we are talking about GPIO. GPIO implies general purpose input-output. But these same GPIO pins can be configured to perform special purpose or special functions. These are also known as alternate functions, and we will do this when we are trying to configure peripherals such as the UART, the PWM, the ADC, etc. Because the UART requires a transmit and a receive line, and these transmit and receive lines are pins. They are general purpose pins, but to say that we want to use them for UART transmit and receive, we have to internally configure these pins to act as alternate function pins or special purpose pins. And the same for the ADC. We have to configure the particular pin where the sensor is connected to act as an analog pin. Otherwise, in its default state or in its general state, it's a general purpose input-output pin. So this is what we mean when we say general purpose input-output and special purpose input-output. And you understand this further when we start configuring our various peripherals. Okay. Now, let's talk about the common registers in the GPIO module. This is just an overview of all GPIO modules, not just our ARM microcontroller GPIO modules. So any microcontroller at all, its general purpose input-output module would have at least two registers. One register is known as the direction register. This register is used to set that pin either as input or output. And the other register is known as the data register. This register is used to write to the pin or read from the pin. These registers exist, but they might exist with other names. For instance, in some designs like the ST microelectronics, the direction register is known as the mode register, and this allows us to configure that particular pin in at least 4 different modes. Okay, so this is an overview of GPIOs. Right, now let's talk about other parts of the MCU that we would interact with, some keywords that we would keep mentioning. Over here, we are looking at the buses inside our microcontroller. We shall take a look at the block diagram, and when we do that, we would see that there are 2 buses. There is the AHB, known as the Advanced High Performance Bus, and there is the APB, known as the Advanced Peripheral Bus. The AHB is a newer bus, and this is faster. As you can see over here, we're saying with the AHB, you need a single clock cycle to access peripherals. Whereas with APB, you might need a minimum of 2 clock cycles. The reason why this is important is that some peripherals, you can decide to access them faster or slower. In a microcontroller like the Texas Instruments microcontroller, the GPIO port can be accessed both by the APB bus and the AHB bus. That is by design. So what this will mean is that if you want to access this faster, if you want to access it with a single clock cycle, then use the AHB bus. But if you're fine with accessing it in its normal mode, you don't require extra speed for access, you can stick to the APB bus. So when we start looking at the documentation, we'll be referring to the buses. We'll find which module or which peripheral is connected to which bus in order to be able to enable clock access to that particular peripheral. Okay, so now let's talk about our microcontroller clock sources. So we have 3 options for our clock source. We have the on-chip RC oscillator. RC stands for resistor capacitor. So this is the least precise clock. Also, you can connect an external crystal to the microcontroller, and this gives more precision than the on-chip RC oscillator. And thirdly, we have the PLL. This is known as the phase locked loop, and this allows us to actually program the clock. The PLL is a module that sort of takes an input clock and then reconfigures it to bring out an output clock or output frequency that is higher or lower than the input based on the circuitry of the PLL. Okay, so these are the options we would have, and we shall visit the clock tree and the clock diagram when we start dealing deeper with timers. Okay, so that's all there is for this very short lesson on GPIO. I'll see you in the next lesson. So the takeaway, just to summarize, GPIO pins, microcontroller pins, are arranged in ports. Example, PA1, port A pin 1, and general purpose input output. Those same pins have special purpose or alternate functions, and we can call these alternate functions as their special purpose. And also, all MCU GPIO modules have at least two registers, the direction register and the data register. The direction register is for setting the direction, whether the pin should be input or output, and the data register is where the data is. So we can read the data from this register, or we can place the data inside this register. Okay, and also we said there are two buses, the advanced high performance bus and the advanced peripheral bus, and then we stated our clock sources here: on chip RC oscillator, externally connected crystal, and the phase lock loop. So this is a very quick overview. We're going to spend a lot of time in the documentation visiting each and every one of these, so you can think of this lesson as getting
Audio Jungle.